Hey, geometry students. In this lesson, we are going to be learning about cylinders. In fact, we're going to be learning how to find the surface area, the lateral area, and the volume of a cylinder. To get started, let's just remind ourselves what the definition of a cylinder is. We define a cylinder as a three-dimensional figure with two parallel circular bases and a curved lateral surface connecting them. Now, what that can mean is we could have a cylinder that looks like we're used to seeing. That would be this kind of cylinder where we have one circular base on top, a parallel circular base on the bottom, and then the bottom and top are connected by a vertical backing like this. Okay, this would be an example of a cylinder that you're used to seeing. However, there is another type of cylinder that fits the definition. This, by the way, the one that you're looking at here is called a right cylinder because it stands perfectly upright. What if I took one of the bases, though, and I moved it off to the side like this? Is there a way for me to connect these two bases to still make a cylinder? According to the definition, there is. And all I need to do is instead of connecting with a rectangle shape, so I was using perfectly vertical lines, I'm going to connect with a parallelogram type shape here. And let's just see what this looks like when it's finished. So we got to just make this bent over like that. I don't know that I'm going to be able to get this perfect. Hey, look at that. That's not bad. This is known as an oblique cylinder. Now let's just see if this still fits the definition. Um, so just to make sure, do I still have two parallel circular bases, one on the top, one on the bottom? Yes. And do I still have a curved surface connecting them? Yes. So this is still a cylinder. It's just not a right cylinder. But here's the thing. Anything we learn about cylinders today also applies to this kind of cylinder as well, unless it specifies that it's just a right cylinder. All right, what is the base of a cylinder? The base of a cylinder is one of the two circular surfaces, one, two, those two parallel surfaces that define the cylinder. The altitude of a cylinder is a segment that's perpendicular to and has endpoints on, now pay attention to this last phrase, the planes of the bases. If all cylinders were only right cylinders, anytime I connected the bottom base to the plane containing the top base, it would always fall somewhere in the circle of the top base, right? But because we can have oblique cylinders, like let's say I started drawing a line from this point over here on this bottom cylinder, and I tried to draw it to the top base, it's never going to hit the top base. If it's perpendicular to the bottom base, it's going to go straight up, but the top base is slanted away. So instead, we say it has to connect to the plane containing the top base. So whatever this plane is here, let's see if I can approximate what the plane looks like here. So whatever this plane is that contains my top base here, this line has to connect to that plane there. Okay, so we're going to get rid of that and that. Now you know what the altitude is. Lastly, what is the radius of a cylinder? The radius is the distance from the center of one of the circular bases to a point on the edge of the circular base. Just the radius of a circle. The bases are circles. The radius is what you're used to the radius of a circle being. Now, we're going to get into some formulas related to a cylinder, but before we do that, it's kind of interesting to take a look at the net of a cylinder. This is the net of a right cylinder. The net of a right cylinder has a rectangular area when we unfold the curved lateral surface, okay, and two circular areas. Hey, if I was going to find the area of all of this, what would I have to do? I'd have to have the area of this rectangle, and I would have to add to that the area of the two circles. We're going to be doing that in just a little bit. Now, what are the length and width of this rectangle? The length is the same as the perimeter or the circumference, we would say, of one of the circles, 2 pi times the radius. That's where this 2 pi r comes in. So when I unfold this from around the circle, we find that the length is the same as the circumference of a circle. The height is just the height of the cylinder, however tall my cylinder is. Now, I said that this is the net of a right cylinder. The net of an oblique cylinder looks exactly the same, except instead of having a rectangle, you have a parallelogram. But do you remember that the formula for the area of a parallelogram is the same as for a rectangle? It's just length times width. Okay. But the width is a little different, kind of, because it's the height of the parallelogram. So it's not like the length along the diagonal side. It's just going to be like the altitude, right? But it's the same sort of thing that we see here. So that's why the formulas are going to work for both right cylinders and oblique cylinders. All right, let's take a look at some of those formulas. First of all, the lateral area. Remember, the lateral area is the area of the faces, not including the bases. For a cylinder, the lateral area is going to be the area of the curved surface of the cylinder, not including the two bases. And to get that, we just use what we have in our net here. It's just going to be 2 times pi times r, so the circumference of one of these circles, times the height of the cylinder. We'll use that in just a little bit. The area, the surface area of a cylinder is going to be that lateral surface area plus the area of the two bases. Okay, so we just pi r squared gives us the area of one of the bases. We're going to multiply that times 2 because the bases have to be congruent to each other to make this kind of cylinders that we're going to be working with. By the way, what would happen if one of these circles was bigger than the other? Can you kind of envision, like, if this top cylinder was bigger than the bottom one? You'd end up with more of a conical shape. It technically is called a frustrum, probably because it's so frustrating to work with. It's not really a cylinder. So one other thing, I don't know if we've said it or if it somehow came out in our definitions, but the two circular bases of cylinder have to be congruent to each other. And that's going to be true here. So all we need to do is find the area of one of the bases, multiply it by 2. Pi r squared times 2. That's why it says 2 times one base plus the lateral surface area. And then if I'm expanding that equation out, it's going to be 2 times pi r squared, because pi r squared is the area of one of the bases. So multiply that by 2 because there's two bases, plus the lateral surface area, 2 pi r times the height. The volume of a cylinder is much simpler to calculate because it's just one equation. It's just pi r squared, the base, the area of the base, times the height. That should be a unsurprising thing for you because volume is usually base times height, area of the base times the height, and it's no different in a cylinder, area of the base times the height. All right, let's get to some practice problems and see how these formulas work in actual problems. Find the lateral area of the cylinder in terms of pi. I like these in terms of pi questions because they're usually very easy to do. We don't have to use a calculator for them. So letter A is simply going to be, let's see, we need the circumference times pi to get the lateral area. So that's going to be 2 times pi times the radius of 12, and then times the height of 22. So let's see, 2 times 12 is 24. 24 times 22, I am going to plug into a calculator. Be nice if I knew that one off the top of my head. 528. So this is going to equal 528 times pi. I guess I'll do the right thing and we'll just grab the shape of pi here. There we go. Good enough. Okay. So I'm 528 pi should be the answer to the first one for the lateral area, and that's going to be in inches. And then let's just make sure we did that one right. There it is. Oh, inches squared though, because it's an area, not just a linear measurement. All right, B, find the total surface area of the cylinder. Now, surface area includes the lateral area and the bases. So I'm going to have to do the same thing. 2 pi times the radius times the height, okay? That gives me the lateral surface area. And then I need to add in the surface area of the two bases. So 2 times the area of one base is pi r squared. So I'm going to do pi times 35 squared. All right, so let's punch this into a calculator and find out what result we get. So here, 2 times pi times 35 times 50. That's my lateral area. And then the bases are 2, because there's 2 of them, times pi r squared. Pi times 35 squared. That gives me 18,692.5, 18,692.5, 18,692.5, and that's going to be, to the nearest centimeter, so 0.3. Let me just double check that. Oh, no, it's going to round down because it's 0.47. So 18,692 centimeters squared. Let's just see that we did this one right. That's a lot. That's a big number. We're going to end up with big numbers for a lot of these. All right, next we need to find the volume of the right cylinder over here to the nearest foot. The volume is a really simple equation. It's just pi r squared times the height. So here I know that oh, and by the way, I'm on this cylinder down here. Pi r squared times the height. So this is going to be pi times 9 squared. 9 squared is just 81, so I'm just going to plug 81 in right away, times 17. So pi times 81 times 17. Let's go ahead and calculate that. Pi times 81 times 17 gives me 4,326. So we're going to write 4,326, and this is going to be in feet squared. Let's make sure we did this one right. 4,326 feet squared. All right, now this last one's going to yield just a huge number because we're talking about a silo, a farmer's silo in square. Is it cubic feet? Oh, hey, makes this. This is volume, so this is cubed, and this is going to be the storage capacity of the silo to the nearest. And again, this is going to be in cubic feet because we're looking for volume. So a silo has a radius of 75 feet and is 150 feet tall. What is the storage capacity of this silo to the nearest cubic foot? So again, this is going to be pi. Which formula am I going to use? Volume. The storage capacity is volume. So it's going to be pi times the radius squared times the height. So this is going to be pi times 75 squared. I don't know that one off the top of my head. Times the height, 150. Pi times 75 squared times 150. Pi times 75 squared times 150 gives me, ooh, look at that doozy of a number, 2,650,719. 2,650,719. We'll put in some commas to keep our numbers straight, and that's going to be in cubic feet. Not going to forget my label this time. And let's just make sure we did that right. 2,650,719. All right, now you know how to work problems. This is actually a pretty straightforward lesson, things you've done before. Go ahead and work the problem set for next time.